Something strange happens the moment you decide to look inside an atom. Not metaphorically, not philosophically, literally. Richard Feynman warned us about this decades ago. He didn't whisper it. He didn't hide it in equations either. He said it plainly, almost casually, as if talking about a trick of light or a child's toy. If you think you understand quantum mechanics, you don't understand quantum mechanics. At first, that sounds like intellectual humility. But the deeper truth is darker, stranger, and far more unsettling. Because the atom does not behave like a thing. It behaves like a question. The comfortable lie of the solid world before we shrink ourselves down to atomic scale. Let's acknowledge the lie we live with every day. You're sitting somewhere right now. A chair, a bed, the floor. It feels solid, reliable, obedient to common sense. Touch a table, it resists you. Drop a cup, it falls. Kick a wall, it hurts. Everything around you seems to agree on one thing. Matter is solid, but that agreement collapses. The moment we ask a dangerous question, what is this solidity actually made of? Zoom in, past wood grain, past molecules, past atoms. What do you expect to see? Tiny balls, miniature solar systems, hard particles knocking into each other. That's what intuition promises. Reality breaks that promise. Entering the atom is mostly empty space. Not mostly as in 60% or 80%, more like 99.99999999999999999% empty. If the nucleus were the size of a grain of rice, the nearest electron would be kilometers away. So why doesn't your hand pass through the table? Because solidity is not made of matter. It's made of forces, electromagnetic repulsion, quantum rules, probability walls. Already, the story is getting strange, but we haven't even looked yet. The fatal curiosity. Looking inside, here's where Feynman's warning becomes a trap. In classical physics, observation is passive. You look at something, it doesn't care. In the quantum world, observation is an act of violence. To look at an electron, you must interact with it. To interact with it, you must disturb it. To disturb it, you must change what it is doing. There is no neutral observer. The universe does not allow it. And this is not philosophy. This is math. This is experiment. This is fact. The moment you look inside an atom, the atom responds. The electron that refused to be a thing, scientists once asked a simple question. Where is the electron? Seems fair. Every object has a position, right? Wrong. The electron does not have a position. It has a probability cloud. Not because we are ignorant. Not because our instruments are weak. But because position itself does not exist until measured. Before measurement, the electron is not here or there. It is everywhere it is allowed to be, and nowhere specifically. Feynman loved this part because it annihilates common sense. You don't discover where the electron was. You force it to choose. The double-slit nightmare begins now. Imagine this. Fire electrons one at a time through two tiny slits. One electron, one decision. What should happen? Logic says it goes through one slit or the other, but reality laughs. Over time, the electrons build an interference pattern. The the same pattern waves make. A single electron behaves like a wave. Not metaphorically, actually. It interferes with itself, Feynman called this experiment the heart of quantum mechanics. Because every mystery lives inside it. Watching changes everything here. The truly disturbing part. When scientists placed a detector to watch which slit the electron pass through, the interference pattern vanished. The electron stopped behaving like a wave. It became a particle. Nothing else changed. Same setup, same electron, same energy. Only one difference. Someone was looking. Reality noticed. What does observation really mean? This is where people get it wrong. Observation is not consciousness. It's not human awareness. It's not the universe caring about eyes. Observation means interaction. Any attempt to gain information forces the system to collapse into a definite state. Knowledge has a price, and the price is reality itself. Schrodinger's. Warning you, ignorant, you've heard of Schrodinger's cat. Alive and dead at the same time. People joke about it, meme it, reduce it to nonsense. But Schrödinger wasn't joking. He was screaming. He was saying, if quantum rules apply at small scales, then reality itself has no definite state until observed. The cat is absurd because the universe is absurd. We just don't notice it at our size. Feynman's brutal honesty. Feynman never tried to make quantum mechanics comfortable. He said, nature isn't classical, damn it. We want particles to be things. We want waves to be ripples. We want causes before effects. Atoms refuse. Inside an atom, time blurs. Causality bends. Certainty dies. The atom as a question, not an object. So what is an atom? Not a tiny solar system. Not a collection of marbles. Not even a machine. An atom is a set of probabilities, constrained by rules. It doesn't have properties. It offers possible answers only. When you ask a question by measuring, does it reply? And its reply depends on how you asked. The first crack. In reality, this is the first crack. The moment you look inside an atom, you realize reality is not made of things. It's made of events, not objects, but interactions. Not certainty, but likelihood. And Feynman was right. Understanding this doesn't make you smarter. It makes you uneasy. Because if atoms don't have definite reality until observed, what does that say about you? Something even stranger happens after you accept that particles don't have positions until you look. Most people think that's the weird part. It's not. The real nightmare begins when atoms start behaving as if distance does not exist. The assumption that keeps you sane. Your brain survives everyday life because it trusts three rules. Objects are separate. Information takes time to travel. Nothing affects something else instantly across space. Classical physics was built on these rules. So was common sense. So was causality. So was sanity. Quantum mechanics violates all three. At the same time, the birth of entanglement. Imagine this. Two particles are created together. They interact briefly. They share a moment. Then they separate. One goes left. One goes right. Farther, light years apart. Now ask a harmless question. What is the state of particle A? Quantum mechanics answers. It doesn't have one by itself. Its state is shared with particle B. They are entangled, not metaphorically, not emotionally. Physically, a single system split in two. This is the part textbooks soften. Entangled particles are not two systems. They are one system pretending to be two. Space between them is irrelevant. Messa, one and the other responds instantly. Not fast, instantly. No signal, no energy transfer, no delay. Einstein called this spooky action at a distance. He hated it because it destroys locality faster than light. Worse, people try to comfort themselves. No information travels faster than light. That's technically true, but it misses the point. The universe doesn't send information, it simply already knows. The outcomes were never independent. Distance was never part of the equation. The Bell test, reality on trial for decades. Physicists hoped entanglement was incomplete. Maybe particles secretly carried hidden instructions. Maybe reality was still classical underneath. John Bell proposed a test, a brutal one. If hidden variables exist, the universe must obey Bell's inequalities. Experiments were run. Again, again, again. The universe violated Bell's inequalities every single time. No loopholes left, no classical escape routes. Reality is non-local. What? Non-local really mean? Non-local really mean snan-local does not mean far away. It means space is not fundamental. Distance is emergent, secondary, optional at the deepest level. The universe is connected in ways geometry cannot describe. Atoms don't live in space. Space emerges from atomic relationships. That sentence alone should make your head hurt. The universe refuses to be a machine. Machines have parts. Parts are separate. Quantum systems don't have parts, only correlations. Remove the correlations, and the system stops existing as something meaningful. This is why, Feynman said, I think I can safely say that nobody understands quantum mechanics. He wasn't being cute. He was being accurate. Cause and effect start to blur in classical thinking. Cause gives effect in quantum experiments. Measurement gives correlation, gives outcomes sometimes. The effect seems to happen before the cause, not metaphorically, in delayed choice experiments. Decisions made after a particle passes through a system appear to influence how it behaved earlier. Time itself stops behaving. The universe that waits to decide. John Wheeler proposed something terrifying. The universe may not decide what happened until it is observed not just now, but retroactively. The past is not fixed, it is selected. Every measurement reaches backward. Finalizing history, you are standing on quantum rules. This isn't abstract. Your atoms obey these rules. Your brain chemistry runs on quantum probabilities. Your thoughts emerge from systems that fundamentally do not have definite states. You feel continuous and solid only because decoherence hides the chaos underneath. Everything is unresolved. Decoherence. The great illusionist decoherence doesn't solve quantum weariness. It hides it. It explains why macroscopic objects appear classical, but appearance is not truth. Reality is still probabilistic, still entangled, still unresolved. We just stopped noticing. Feynman's quiet terror. Feynman once said the most profound mystery is why probabilities obey the specific mathematical rules they do, not why they exist, why they follow such precise, elegant, terrifying equations. The universe seems to compute outcomes before outcomes exist, as if reality is constantly rolling dice, but with perfect bookkeeping. The second crack in reality. So now we have two fractures. Properties don't exist until measured. Separated systems are not truly separate. This leads to a disturbing implication. Reality is relational, not absolute. Things exist only in relation to other things, and observers are not outside the system. They are embedded inside it. What this means for you, you are not a passive witness. You are an active participant. Every observation you make is an interaction that shapes reality's outcome, not in a mystical sense, in a physical one. By the time you reach this point, one uncomfortable truth should already be clear. Reality is not sitting there, fully formed, waiting for you to notice it. Reality is unfinished. And the final piece of the puzzle is the most dangerous one because it drags you into the equation. The question physicists tried to avoid for decades. Physicists asked safe questions. How fast? How big? How likely? They avoided the forbidden one. What exists when nobody is looking? Classical physics answered confidently. Everything. Quantum mechanics hesitated, then refused to answer at all. The wave function. Reality's ghost. At the heart of quantum theory lives a mathematical object called the wave function. It contains all possible outcomes, all potential histories, all allowed futures. But here's the catch. The wave function is not reality. It is a description of what could be observed before measurement. Nothing in the wave function is actual. It is not hidden. It is not waiting. It is simply undecided. Collapse. The most mysterious event in physics. When a measurement happens, the wave function collapses. Possibilities vanish. One outcome survives. But physics cannot explain how or why this collapse occurs. It just says, this is what happens. No mechanism, no cause, no physical process. The most precise theory we have ends with a shrug. Consciousness. The accidental suspects and physicists made a dangerous suggestion. Maybe consciousness causes collapse. Maybe reality needs awareness to become real. This idea terrified everyone. Because if true, then before observers existed, the universe was what? A blur. A superposition. A question without an answer. Most physicists backed away quickly, not because it was disproven, but because it was uncomfortable. The observer is not optional even if consciousness isn't special. One thing is unavoidable: observation. As part of the laws of physics, you cannot remove the observer from the equation. There is no view from nowhere. Every description of reality depends on interactions. Reality is not objective in the classical sense. It is contextual. The universe as information. This leads to a radical idea. What if the universe is not made of matter? What if it's made of information? Particles become bits. Fields become rules. Space-time becomes a storage system for correlations. John Wheeler summarized it in 3 words: It from bit. Not matter first, information first. Time starts to crumble if reality is information, then time is not fundamental either. Quantum equations don't care about now. They describe correlations between events, not flows. Time emerges when systems interact and record changes. The universe does not tick forward. It updates the past. Is not safe. This is the most disturbing implication. If observations finalize outcomes, then the past is not fully real until it is recorded. Experiments show that present measurements can determine how the past behaved, not how we remember it, how it physically occurred. History is not written in stone. It's written in interactions. Why? You feel real anyway, so why does your life feel continuous? Why don't you feel like a probability cloud? Because your brain is a decoherence machine. Trillions of interactions. Every second lock in outcomes. Possibilities collapse so fast you never notice. Your sense of self is a stabilized pattern, not a thing, a process, not an object. Feynman's final honesty. Feynman never offered comfort. He said the rules work. They predict experiments perfectly. But why they work? Nobody knows. And anyone who claims to know is lying to themselves or to you. The final realization when you look inside an atom. Something strange happens. Not just to the atom, to you. You realize reality is not made of solid things. Observation is not passive. Separation is an illusion. The universe does not commit until questioned, and the most unsettling truth of all. You are not watching the universe. You are participating in it, the question that never goes away. So now ask yourself slowly, if reality needs observation, and observers are part of reality, then what is the universe doing right now, in places no one will ever look? Quantum mechanics does not answer. It just smiles and stays silent.